Yeah?
What's the difference between them?
Too late, physics has started.
Yeah.
So I'm answering the physics questions now. So, left hand and right hand, yeah? When you have a current, you can use the right hand grip to know the magnetic field direction. When you have a current inside a magnetic field, you can use your left hand. So this one is the current, this one's the magnetic field. So if the field is going this way, the force will be up. So we want to turn up like this. Yeah?
Do it. Says again, that too.
Who are you talking to? Omar? Yusuf?
Oh my.
Yeah. And then right hand rule is when you have a generator for making electricity. So this is the force where you turn the wheel. This is the magnetic field, and then this is the current.
The right.
For making electricity. Yeah. Is okay? Where's my bag? Oh. Lee! You're so helpful. Can I have the bag, please? I'm sorry I don't believe you. You understand, don't you? No, do you? Because you might be thinking, after all I did for Stephen, have I not proved myself? Why doesn't he believe me? But I need to think about the question more. And more importantly, I need to drink more coffee first. You see, if I was young like you, I would have lots of energy in the morning. Right? You probably get out and up so easily from bed. You just wake up full of energy. Is it? Oh, okay. Half-life, if you can write that down, please. Do you want to put the cap on as well? Alright. Half-life. We know that n equals m0 e minus lambda t. Do you remember this equation? Yes? We also know from maths class what this graph looks like. What's up, Andrew? You ready to go?
Yeah.
Rock and roll? Do you remember what this graph looks like in maths? The shape of it?
Got it.
What? Make it good.
The answers
Yeah?
for this question.
You're leaving us hanging here. What was wrong with what I did?
You had a 310.
Yeah?
That was wrong.
What should it have been?
We just cancel it out.
Why cancel the 310?
Because it's too big.
But you can go up to 360.
The 310 is before. When you multiply it by 2, you get 620. That's true. See? Circle method. Works every time. Hater.
I don't know about this, Faisal. I'll come back to this question though. What does the graph look like, Andrew?
An exponential graph.
Oh, funny. Yeah, funny. True that. And what shape is that exponential graph? Exponentially shaped, is it? Could it possibly look like this? Seems legit?
Yeah.
Yes, exponentially decreasing. What's interesting about this graph is that the time required for half to decay is regardless of when we look at it. Let me give you some data to make this clearer.
What?
What?
The time required for half? What does this mean?
That's why I said some sample data will help make this idea clearer. Now, at the beginning we have 100 moles. 1 second later we have 70.7 moles. 2 seconds later we have 50 moles. If I start here, how long until I have half? the number of moles?
2 seconds.
2 seconds.
Yeah.
If I start randomly here, what's half of 12.5?
6.2.
And how long until that happens? How many more seconds? 2 seconds. So regardless of where I start, it requires 2 seconds to lose half of it. This time, 2 seconds, is called the half-life of this sample. You get the idea? So the definition is half-life is defined as the time required for exactly half the sample to become non-radioactive. Stop touching yourself in
I
class,
have a
please.
question. For those kinds of questions
Yes.
in the trigonometry,
Yeah.
we give different answers. If let's say we give they have 5 answers, but let's say we give 6 answers.
And one of your answers is wrong?
Yeah, because they're 5 only.
I don't know.
Because like over here it says answers outside the range can be ignored. But what if it's in the range but it's wrong?
I don't know. I'd have to read the marking scheme really carefully. When possible, I try to interpret the marking scheme to the advantage of the student, not to the
Yeah,
disadvantage.
so no penalty is given for wrong answers.
No, I can't even say that because it depends on their exact wording. I'm sneaky like that. I'll give you an example, okay? In the physics exam, students were asked to draw a graph. And most of the time for the graph they had to draw, they needed to plot log of the value rather than the value on the graph. This is something that we've done before in physics, like in the electricity section, yeah? The capacitors, yeah. But for some weird reason, last year's exam, it just said plot the graph. It didn't say, it said plot whatever it was, y, I'll just say. It didn't say plot log y. So 2 of the students plotted log y, and I understand why they did, because that's what you usually do. So what was I supposed to do? Give them 0 marks? Like, that didn't feel right. So when I was looking at the marking scheme, it said give 1 mark for the plot. Like, it never said the right plot. Or 1 mark for the shape. No, it wasn't it. 1 mark for the units. So yeah, they had the right units for their graph, just not the graph that they asked for. So I can't even say FISO for certain what would happen in situations like that. But I can promise you I will interpret it always to the advantage of the student. And if they don't like it, well then that's their fault for not being more explicit in the marking scheme. Okay, did you write this down? Question
Yeah.
there?
The time required for exactly half the sample to become non-radioactive.
Yeah.
What is that?
What do you mean, what is that?
Like, the atom is like...
It's emitting alpha, beta, gamma.
Yeah.
And as we learned last time with the nuclear equations, it transforms into a different substance,
Yes.
which sometimes is not radioactive. So, for example, uranium will ultimately perhaps decay into lead. So, if you have a kilogram of uranium, how long until half of it is uranium and half of it is some stable material like lead?
And then that atom that was emitting all these alpha, beta, and omega, it would just stop. It wouldn't decay anymore.
No, correct.
So
Once it's finished releasing alpha, beta, gamma and it's stabilized into some other atom like lead, then it doesn't continue decaying. It only decays into something stable. Yeah? Okay? Continue? Yeah. Right. So this is the formula to calculate half-life, and I'll do the proof really quickly, but it's very straightforward. If you have n equals n0 e minus lambda t,
What's the unit of n?
number of atoms, you could use moles if that makes you happy. You want to know what is the time until you have half of them left. So you want to solve this. So log a half equals minus lambda t. So the time is minus log a half over lambda. I can bring the minus up to make it a minus 1 on the power, and then that would be log 2 over lambda. So that's the time for it to decay by half. Log 2 over lambda, or as it's sometimes written in the formula book, although I think they changed it. They put out a decimal form, but I'm pretty sure that's back to log 2. The proof is quite short, and that's the result there. I use this little symbol here to mean half-life time, T half. T half is log 2 over lambda. Okay. You got that? Got that, guys?
Could I look at the formula?
Yeah, I don't know why I did that. I really don't. Why didn't I just put the lambda on the other side? Oh, you know what? Maybe because that's how it is in the formula book for some reason. Looking at this should make it clear that lambda is in units of per seconds, because time is in units of seconds, and you don't want any units on the left because you don't have any units on the right.
Stephen, I'm sorry, I'm still confused. Okay.
Are we back to the alphabetic gamma?
Yeah.
Go for it.
Okay. Earlier we said that the half-life is this 2-second difference of halving it up until it becomes 0.
It'll practically become 0. Practically.
No,
Not exactly.
technically.
Well, technically it will become 0, and practically it does become 0, but mathematically it doesn't become 0. Yes, now we're clear. Okay, go on.
So,
Wait.
the half-life in the table that we saw, the half-life was
2 seconds.
2 seconds for it to become half the amount it was.
Correct.
But
then-
for a certain...
Yeah. He's cool with that.
Yeah.
No, he's cool with that.
But then, over here, it's to become unstable.
Yeah, what probably is not...
To become stable, sorry.
Yeah, what you're not seeing here is, this is how much of the radioactive material I have. What you're not seeing is how much... I'm not counting the part that has become stable. So here, when this 100 becomes 70.7, the other 30 hasn't vanished off into the regions of nowhere. It's just become a stable material, which I'm not counting anymore. I'm only looking at how much of the unstable material I have. I don't know what else to say. It's a bit like saying, if you take a block of ice, I said the half-life of ice is how long for half of it to melt away. Of course, we all know that the other half hasn't just disappeared, it's just become water. But when I'm looking at the ice, I don't care about the water that's seeping out. I just want to know, how much ice do I have left? You know, it's kind of like that. Is it an English thing? Like, is it the way I phrased it?
No,
Or
it's
conceptual?
conceptual.
Okay. It's okay or not okay?
You know, it's
Sure?
Yeah.
Okay. Continue?
Only if it's not true.
What?
It's okay.
I don't know what you're saying, but what else? Okay, let's do this one together. Does anyone know what C14 is? Yes, carbon 14, and it is an interesting one. It's a naturally occurring one. Yeah, and its half-life is a ginormous 5,730 years, meaning it would take 5,730 years for 1 gram of carbon 14 to become half a gram of carbon 14, and I believe the other half of it, I'm not sure, it probably, I don't even know what carbon 14 decays into when it decays into something stable. Let's just say carbon 12, although it might not be that. So it'll take 5,000 years for 1 gram of carbon 14 to become half a gram of carbon 14, and then the other half to stabilize as carbon 12 or whatever it becomes. Who cares? It's the radioactive one we're interested in. So, part 1, please change the half-life into seconds. I think we can all do this. Please, no cultural Arab music in class, please.
Every 40 years, 1 year will become 36.
No, don't.
We don't worry about that in physics. We pretend it's 365 every year. Every 4 years you have one extra day.
Yeah.
But you don't do that every 4 years. Did you know this? So every 4 years you have one extra day because it's 365.25. But it's not 365.25. It's like 365.24. So every 4 years you have one extra day, but every 400 years you skip that one extra day. So for example, 1900 should have had one extra day because it was every 4 years, so it was a 4-year one. But 1900 was 400 years since the last time we skipped an extra day on the 4th year. So it means in the year 2300 does not get the extra day when it should. That would be the next time it happens. So most people don't know that. So you might be thinking, I'll be smart and I'll say every 4 years it has an extra day. But every 400 years you skip that. Yeah, so we just pretend it's 365 for every year.
1.8 times 10 power of 11.
Did you all get that?
Yeah.
Now, the decay constant is log 2 over this number. So can you calculate that?
3.8 times 10 to the power of negative 12.
Did you all get that?
I don't know myself.
Okay, but can you at least write it down? I think we can trust Faisal. And if you can't trust Faisal, you can trust Wong. 3.8 times 10 to the minus 12 per second. Okay, part C. Yep. The molar mass of carbon-14 is 400 grams. How many moles are in 100 grams?
1,400.
That is so wrong.
Molar mass, how many moles? Moles equals
What is it, Lee?
100.
7.14 moles.
Oops.
Small type in miscalculation. Now look, I actually say in number part D what carbon-14 decays into, Andrew. It decays into nitrogen-14. So carbon-14 will decay into nitrogen-14. In a 100 gram sample of carbon-14, how long until you have 25 grams of carbon-14 remaining?
Remains for 75 grams.
I won't say anything. Okay, what answer did you get? 1?
3.6 times 10.
Oh, give it to me in years. So, it's this here.
So 11460.
Yeah. Because what's happening here is, how long until you go from 100 to 50? 5,730. 50 to 25. Another 5730.
What's the end of that?
Nothing important. I don't care about it. Yeah. I don't know if you've done this word in English when you're looking at answers, like in the writing exam, but some answers are sometimes called distractors. Have you heard of this term? It's information that is...
Distract you away from the...
Yes. Yeah. The nitrogen-14 here is not important to solving this.
They did this a lot in physics.
I wouldn't say a lot.
For the sake of fun.
Well, it is fun. Right, now, lastly, I'll let you try this one. How long until you have less than 1 gram of carbon-14? Yeah, there is. You could use this N formula, where this is 1 gram and this is 100 grams. But I don't want you to do that. I just want a rough estimate. We'll do it together. No, we'll do it together.
A minute.
Starting
now.
now.
Nothing.
Nah, just give me a rough answer using what you learned today about half-life. Look, I'll give you a hint.
Half-life is,
Mm.
it goes half. So how long until it? We started with 100 grams.
5,
So half. So
6.
100 divided 100 is the answer. 5 by 2, 1, 2, 3, 4, 5, 6, 7, 7, yeah.
7?
So 5, 7, 3, 0.
I got 6. Are you sure, dude?
62 at one point.
Oh yeah, sorry, 7. Hee.
7 what?
Yeah, so what's happening here, they didn't want me to say it, but you start off at 100 grams. After 1 half-life you have 50. That's the definition of half-life. You start with 100 grams. After 5,000 years you have 50, because that's the half-life.
Okay.
So after 1 half-life of time, you have 50. After another half-life, you have
25.
another,
12.5.
and continue that way. After 7 of these, you're at less than 1 gram. You've cut 100 down to 1 by halving it 7 times. So the answer is 7 half-lives, which is 40,000 years.
So this 5,730 years is for it to go from 100 to 50.
Yeah, that's what a half-life is, yeah. Right, so
They have 1 hour or 2.
we have 2.
If the timetable says 1, that's...
I know, I'm stealing the second hour because you should have ESAP. No. Okay, sorry, I need to be more careful with my grammar. You usually have ESAP, but you don't have ESAP today. Correct or incorrect?
Bingo!
Correct? Now, yes, thank you. You used to have EAP at 10 o'clock. ESAP. You used to have a non-important subject at 10 o'clock. Now I've replaced it with an important subject. Clear? No. Okay, continue. No reference required. Alright. Just do this question and we'll go on to the next lesson.
Do you have the answers for the last lectures?
Like the last question,
Yeah.
like how can we show our work?
Yeah, how can you show it?
Yeah.
We start 100 divided by 2.
Yeah.
Divided by 2.
You wouldn't do this in the exam. All I'm trying to get you to do is to use half-life to estimate the answer. But you can work out the answer exactly.
Using the M.
Yeah, you can use, guys, you know how to do this because you can use this formula to get the answer exact. Did you work out this? Yes. Do you know this? Yeah. Do you know this? 1. So you have log of 1 over 100 over minus lambda is the time. And it'll be roughly 40,000 years. Yeah, okay. Anyway, this is what I want you to do now. And Lee, that's what I want you to do in part D, is how long until exactly Yeah? Okay. Try it now, please, Lee.
Should the answer be in days or
That is up to you if it's not specified. I recommend using seconds because that's what's in the formula. Which answer did you mean, Warren? Yeah, no, for that I'd use days. No. Yeah, of course you can, go ahead.
Well, yours.
Wow. What happened to you? Me too. You didn't miss too much, Yusuf. For the first bit of the class, nobody was here except for Faisal and Lee, who's gone. So we did a bit of a math tutorial that they had, and then after that we had the half-life lesson.
One math.
Yeah.
Two guys, one math story.
Yeah, that's what I made the video. If you don't understand the reference, you're terribly innocent, and congratulations to you. I salute you. And then after that we did a lesson on Half-Life. And Half-Life, I think we can all agree, is not too difficult.
Do you think I'm better?
I did not say anything bad by this title. In fact, the title was just descriptive. It was 2 students and 1 maths question.
Yeah.
If you take it to some dark and dirty place, that's your business.
Save that holding the cup.
There are 2 dogs in dirty places.
That is merely coincidental. It's not like the people who watch this on YouTube will get this reference anyway. No. I sometimes get random comments on the YouTube videos. So the one where Juan was talking about the ghost, someone posted saying, "Thanks for the video. Why is someone talking about ghosts in the video?"
Who is that?
I don't
No. What is that?
Remember in one lesson we were talking about this, we were saying like ghosts and fairies and unicorns. You believe in them all.
Ah.
Yeah, remember that? Yeah. So what's on your mind?
But who is that?
I don't know who it is, some YouTube viewer.
Oh. Then what's he saying? Oh, he
He was like, she's so beautiful, I can tell from her voice.
No.
He has a crush on you, just from hearing your voice. Talking about ghosts.
What?
This one.
I was asking Lee where class is, yeah?
He has
Yeah.
a very long sense of humor.
What's he said? What class are you in? No class anymore. La 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 la. What? No class? It's a joke, stupid. Yeah, Lee needs to work on his sense of humour.
And sarcasm.
And sarcasm.
And sarcasm whatsoever.
I still don't get that joke he told a few days ago.
No, his sarcasm. It was like he does not get sarcasm.
There's a trick joke. He was like gonna make you practice like the denial and opposite, and then he'll tell you what the opposite of you love me or you hate me or something like that, and then you say I love you, and you say oh thank you, and he starts laughing.
Ah, okay. It was one of those things that work better in your head, I guess. Yusuf, I don't know if can you do these? Have you studied this before?
No.
Yeah.
T half.
He was for A which formula?
See, A equals minus lambda n, isn't it? Yeah. Yeah. You should listen to Fawon. She's much smarter than you.
GK constant.
Why not is that?
Depends.
You don't know.
Half life here.
They always say that, yeah.
Equals log 2.
Yeah. Which is what you want to find.
So,
No,
what
AO.
You're looking for AO,
Uh-huh.
but you don't know what A is in that formula.
Oh.
You know nothing about A. You only know things about N.
What's the lambda
What do you mean, what's the lambda? The Greek letter.
in this question?
You can use the formula to calculate it from literally today's lesson.
But it's
Have I given you the half-life?
never mind.
That's right.
Isn't the 2.8 the GK constant?
No, that's the half-life. That's the T.
Yeah. Yeah. You see, the trick was I said it was half-life for 2.8 days.
What's the N?
Oh, Mr. Stephen, you're so tricky with giving us the information clearly.
First one was 5 days.
5 days?
Wait.
That seems a bit small. Okay. I retract my answer.
14.
That sounds more like it, yeah.
It starts at 25.
Yes.
So how 14? 5.
Oh, because it's number.
Yeah.
It's 5 times. 5 half-lives. 5 times.
Yeah, 5 half-lives.
Yeah.
Yes. And then
How can you be both so smart and so stupid at times? It's like you can do difficult problems and then at the same time you're like, oh, plus.
They were talking about track as well.
Yeah,
They were away from many.
yeah. They're saying we don't get your jokes. You're showing me your chat.
On the Where's the shit that made jokes? I was like, he's funny. Cold jokes. Like cold doctors.
Yeah, like when nothing to do, you want okay, like this.
Lame.
Exactly.
Lame jokes?
Sometimes it's like that.
After you
I think I'm wrong.
okay.
Yeah, you're good at these jokes. Yeah.
Oh, so that was what he was aiming for.
Oh, I see. Okay, yeah.
The end is a one.
No, it's interesting, but if you think about it, it's not. Yeah, but wait, watch this magic now. N is number of atoms, right? But if you multiply both sides by, let's say, Ma, which is the mass of the atom, number of atoms times the mass of the atom is just the total mass. No? So, you are free to use both. You have so many choices. You can use number of atoms, number of moles, or mass.
If you use number of atoms, you need to times the hour, the 6 times.
No. Wait, what?
Number of atoms. 6
Hour by
times 10 to
1
the 23.
Hang on. No, I'm not sure you're getting this. This is if you're using atoms. Right? This is if you're using moles. And this is,
If you're using mass.
yeah.
Can you use the mass of the
You're free to use any of these. So, for example, yeah? Alright, okay.
But the question C, it needs to...
Now, this is in C,
It needs to...
it must be atoms, because the definition of activity is destruction of atoms per second. So you must be using atoms for part C. But you don't need to for part D.
What's our grammar response?
6.03 times 10 power 25.
Yeah, the answer. But in the exam, I don't think they give you any less marks if you forget the sign.
For every question we get 1 mark for the units, right?
Yep. Well, no, that's not true. What happens is, if the answer is, say, 50 kilograms and it's 1 mark for the answer, then you get 1 mark for getting the 50. Okay, this is how it works for the units. Imagine a question at 5 marks, and you got all of it right except for the units that's wrong. You get 5 out of 5 minus 1 penalty mark for the unit, so you get 4 out of 5.
The A1.
No, for any question.
No, let's take the A1 one.
No, it's not quite like that, because if the question only had 1 mark and you got the right number, you get 1 out of 1 minus a penalty of 1, so you're at 0. So it's not like you're thinking about, oh, you don't get the last mark, or you do get the last mark, or you don't get a certain mark. If you have the number right, you get all the marks minus 1. So it means that if the question had 1 mark, then you get nothing. If it had 10 marks, you only lose 1 of the 10 marks.
So if you just try the unit, you don't get anyone.
Yes, this is what you're thinking. Is there a mark going for the unit? No. It's not like 1 mark here, 1 mark here. You get penalized for missing the unit.
It's like I said to you.
I guess. I don't know. And I've had one student, and she got a C, and she should have got a B, but she didn't write any units in any of her answers, and the penalty took her from a B to a C. And she needed a B for her first choice. And I tell this story every year in the hope that no one will do that thing. And mostly when I tell people this story, they're like, dang, they stopped doing it. So there's been an improvement in the use of units in the exam. Most people now write a unit on every answer. Some people forget to for some answers.
Guess. The guessing would just like take 1 mark, which is the...
It's better to guess a unit than have no unit, but best of all is to have the right unit.
A is equal to minus lambda, and N should be the number of atoms
Must be, yes.
into times
Avogadro. If you're given it as moles, which I think, do you have, yeah, you'll have to do that here. Yeah, you'll have to do 25 divided by 222, multiply Avogadro. Guys, have you done ABCD? Now, I don't really care so much about E and F because what are you practicing in E? What topic? Density. What's the formula for density? Yeah, so we can screw E.
What was your seed?
Faisal, I'm talking! F. What are we doing in F? We're practicing something which isn't even on physics, it's in chemistry. Polarity. So again, double screw F. Okay. So we'll continue with the next lesson. Now, Faisal, ask the class your question.
What were your seeds?
What were your C's? Is that a sentence?
Answers for C.
Ah. What were your answers for C?
3 minus 7.
No, it didn't get it.
What did you get used to?
Didn't get that either.
Alright, may I use a calculator, please?
That was your answer for me.
Let's see. What did you want in C? What is the initial activity? Okay, folks. Wait, I'll do it. Listen to me. For C. What's the formula for activity?
A equals minus lambda.
Minus lambda n.
Minus lambda n. Okay, and the lambda, what's the formula for lambda?
2 over T.
Half-life.
Over T. And what's the half-life?
2.8.
2.8 what?
But
Has
if
been
you
second.
don't...
Yes? Hang on, guys, you're confusing me with your talking. Lee, Faisal, 1 second please, while I do see. Thank you, but be quiet. Activity is log 2 over lambda. Correct? No, A equals minus lambda n.
Yeah.
A 0. Isn't this right?
Yeah.
Minus lambda n 0. And lambda is log 2 over t. Right? So,
That is half-life.
what? Isn't that right?
Yeah, that's the half-life.
Yeah. Right. 2.8 times 24 times 3600. Now, do we know m0? We'll have to work it out. How many moles do we have? 25 over 222. And Avogadro's number, 6.02 times 10 to the 23. So my answer is 1.94 times 10 to the 17.
Yeah.
And the unit?
BQ.
Becquerel.
Back.
Becquerel.
Bacon. Bacon.
No! Don't get out the wrong thing. No.
Okay, no, I shouldn't, sorry. Equals. Bequels. I'll put more of a French accent on it.
Isn't there an R?
Mm. It's French. You gonna pronounce it there? Googlebot. Equals.
What about E?
What about E?
E.
What E?
I don't know the spelling.
E?
One spelling.
Oh, E!
Yeah.
Okay, you don't know how to do E? Density is mass over volume. Right, continuing.